This lesson is on finding distances on the coordinate plane. So we're going to try to find some distances between points. So on the first example, it asks how far it is from Lee's house to school. So Lee's house to school, we can see it's just a straight distance there. And so if you look at the scale in the corner here, you can see that each square is equal to 1 mile. So if we can just count the squares between these, there's 5 squares, that'd be 5 miles. The book talks about doing absolute values. Another way of looking at it is x values are the same. Looking at our y values, this point up here is 2 units away from the x-axis. This one's 3 units away from the x-axis. And so that's a total of 5 units, which in this case would be 5 miles. On the try it, they want the distance from the school to the playground. So school to the playground, similar idea. In this case, we've got these pictures that are kind of blocking us a little bit from seeing things. So if you want to go over to the side here, and again, it's 3 blocks away, so that represents 3 miles. There's different ways that you can work these out to find the distances. Kind of a way that I like to do these a lot is actually just to potentially, if I need to, draw a number line and think about what distance it would be from one point to the other. The other option you have, like the book's showing, is doing absolute values and either adding or subtracting. So if you look at the numbers, one of the coordinates will be the same, either the x or the y. The ones that's different is what we'd be working with when we do these. So if the points are in the same quadrant, remember we had 4 quadrants, like 4 sections. If they're both in the same quadrant, then you can take the absolute values and subtract. Okay, furthest from 0 minus the one that's closer to 0. If they're in the different quadrants from each other, then take their absolute values and add those together. Again, just doing the number line, at least for me, that's kind of the way that I prefer to do these. If you look at example 2, the Coulter family starts at their home and stops at a rest stop to eat lunch. How much farther do they need to drive to get to the water park? We're going to simplify things a little bit here. I think what they're doing in the book is fine, but we're just getting a little bit more complicated problems than what we probably need for doing this for the first time. So if we kind of just ignore decimals and fractions and stuff, it's going to make things a little bit better maybe. So if they're going from the rest stop to the water park, again, I modified the numbers here, but if you just look at these, the y values are the same, x values are different. So basically, we don't have any blocks to look at on this one, but if our distance between -85 and -25 is what we're looking at, these are in the same quadrant as each other, so it makes it a little bit easier to look at maybe. It's basically, this would be the same distance as the distance between 25 and 85 on the positive end. So since they're in the same quadrant, we can subtract those, and then the distance between those would be 60. So 60 miles. Okay, again, I know I changed the numbers, so it's possibly changing our answer here a little bit, but that's kind of the idea of what we need to do on that problem. Again, going back to the absolute value statement I made earlier, absolute value of the one further from 0 minus absolute value of the one closer to 0. That would be another way we could get to that point of 85 minus 25. I just feel like in the long term, you're probably not going to remember that kind of formula of absolute values. as much as you'll probably just be able to kind of think about things of how that would work on a number line. So if you look at the try it, it says what's the total distance of the return trip after their day at the water park. Okay, so the total distance for their return trip means we're actually going from the water park to their house. So again, the y values are the same, x values are what's different. So what you might want to do on this one, these are in different quadrants. One thing you could do is just think about from negative 85 to 0, that would be 85. And then from 0 to 65, that would be 65. So if we add 85 and 65, that'd be 150 miles. Okay, again, this is going to be a little different from what the answer is the book would have had because I changed the numbers a little bit, but you know, again, let's just focus on the main idea for right now of how we would work these problems out. Okay, we could have done it with the decimals, but let's just focus on the whole numbers, integers, for right now. Okay. Example 3, we have point B is on the x-axis, has the same coordinate as point A. Point C is graphed at negative 2n. Distance from point A to point C is equal to the distance from A to B. What's the value of n? Okay, so C is at negative 2n. So negative 2 on the x would be over here somewhere. And you might say, well, n, I have no idea where that is. Well, if you look at A, the y value for A is n. So imagine up here somewhere then would be where n is at. So there's C is at negative 2n. And so the deal is distance from A to C is equal to the distance from A to B. Alright, so if we look at this, A to B, B, you might say, well, we don't know what the coordinates are. Well, it's straight down from A, so that must mean they have the same x value. So their x value would be 5, and it's right on the x-axis, so that means we didn't go up or down at all. So 5, 0 would be the coordinates at that point. So if you look from C to A, the x's are different, the y's are the same, so we can actually go ahead and find the distance between these 2 points. And we can just break it down and say, well, from negative 2 to 0, that'd be a distance of 2. And then from 0 to 5, that'd be a distance of 5. So then 2 plus 5, that distance would be 7. So they want us to find the value of n. Well, if our distances are the same, if that distance is 7, that means going from A to B also would be 7. So if this distance is 7, we were at 5, 0. If we're at 5, 0 and we go straight up 7 units, that would take me to the point 5, 7. The coordinates for A, they told me, were 5n. So that tells me that n must be equal to 7. And then if you look at the try it, we have point D is in quadrant 4. And it's the same distance from point B as point A. What are the coordinates of point D? So D is also going to be 7 units away then. So if this is 7 units here, it's going to be 7 units, only it's going to be going down if it's in the 4th quadrant. So coordinates of D would just be 5, -7 then. So this is on page 98. Do you know how? They want us to find the distance between these pairs of points. So in your book, all that's listed there is the coordinates. My suggestion to you would be to use graph paper so we can kind of see what's happening. Some of you might be able to get to a point where you can look at these and kind of figure out what's happening and figure out your distance without actually even graphing the points. But for a lot of people, having the points actually graphed out is going to be a big help for you. So if I graph these points, -5, 2, -5, 6, again, they're going to be directly across from each other, either vertically or horizontally. And my graph is going by ones here, and so I can just count how many blocks between those. So that would be a distance of 4 units. And I don't know necessarily that this is miles or anything like that, so we'll just put units. 4 units is our distance between those 2 points. Okay? If we look at number 5, we're going to simplify things again. Because I feel like this is a little bit overboard for what we necessarily need to know about. So what I'm going to do is just remove the decimals. Okay? If we get the main idea down of finding the distance, I think if we had to, we could probably do it with decimals and stuff also if we were required to, but let's keep things a little bit simple here for now. 4, -3 and 4, 5, we're finding the distance there. So technically, if you were doing it by hand, the y values are different. Start with the one further away, which would be the 5. Absolute value of 5 minus absolute value of -3, or sorry, plus absolute value of -3, because they're different quadrants. We're going to add those together. Or simply, you can graph those and kind of look at this. Count your boxes total. That's a total of 8. So that would be 8 units, which is different than the answer of what they gave you in the book. That's just because I changed the numbers, okay? So technically with what the book gave us, 8 8/10 units would be the answer. I modified it, so our answer is 8 with what I changed it to. And next, if we look at number 6, same idea. We're going to not worry about the fractions here, just to simplify a little bit for ourselves. And so if we graph this, 5, -7, 5, -1, and then if we look at the distance between those, then that would be 6, which actually happens to be the same answer as it would have been with what they had in the book anyway. So if we look at number 7, same idea. I'm just going to go ahead and ignore the fraction parts here just to simplify things a little bit. So -2, -8 is actually going to be just off my chart here. So we'll have to imagine a little bit. -2, -8. My chart only goes to -7. And then 7, -8. So both of those off the charts, just barely. Okay, they're in different quadrants, so technically you could take the absolute values of the 7 and the -2 and add those together. Or if you graph this, if you look at this, so the distance between these 2 points then would be 9 units. There's 9 squares in between these. Okay, and again, you guys if you're using graph paper, what you may want to do, I've got all the graph paper I need because I can just keep duplicating this graph and get as many of these as I need to. But you guys, if you don't have that option, then you can just erase what you did and then do the next problem if it gets too confusing having too much stuff. or you can use, you can make several graphs on the same piece of graph paper. We're not going to be doing like 100 problems or anything, so you're not going to have to use like a whole notebook in order to get an assignment done or anything, but just a suggestion there. On workbook page 23, if we look at number 9, they want us to find the distance from the fishing area to the canoes. Now, fishing area to the canoes, you might notice on this graph, every other box there's a number. So that means they're actually going by halves. So if we're trying to find from the fishing area to the canoes, we don't want to just count how many boxes there are, because how many boxes is not exactly the distance. That's they're only going by halves. So if you wanted to count the boxes and then divide it by 2, that would be fine. Otherwise, you can look at the coordinates of these points and go from there. So the coordinates, if we wanted to map this out, coordinates of the canoes are actually at 2, -2.5. Fishing is at 2, 3.5. So one option, like we talked about, would be, take the absolute values of their y's, since the y is what's different, and then add those together. Adding those together is 5 2/2, which is the same as 6. Otherwise, like I said, if you wanted to count squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. Each of those are only half, though. So 12 divided by 2 is 6. And this is, there's no key here. So all we can do for an answer is say 6 units is our distance. Okay, I don't know if this is miles or meters or feet. Okay, probably a little bit more separated than feet, but anyway, they didn't tell me the units, so that's all I can do, 6 units. If we look at numbers 13 through 15 here, this is similar to the one what we did in the book. So it says the graph shows locations of point U and V. Point W is located at N1. The distance from V to W is equal to the distance from V to U. And then we got some questions. So first thing I would do is graph point W. If it's at N1, N1 means N is my X value. So if you'll notice, point V is N -5. It has the same X value, doesn't it? So what that tells me is I could mark that as an N there if I wanted to. And I can go up to 1, and that would be my point W. That would be the first thing I would do. Okay, that's the point W, which is at N1. And then the first question here, they're kind of directing us for steps to do that's going to help us with our final questions. Question 13 says, what is the distance from point V to point W? So if we look at these, what's different is the y values. The y values are -5 and 1. Okay, so this, they didn't mark it here. This is -5 here on our y-axis. So it's just really finding the distance between -5 and 1 is the distance between these. So the distance between these, I don't have physical boxes or anything. We could kind of make boxes if we wanted to, or we could make this be like a number line here if you want. Okay. But anyway, we're going from -5 to 1. Basically, we've got 5 units getting us back to the x-axis, and then 1 more unit. So, or you can do absolute values and add those together. And that's going to be a distance of 6 units. Okay, so that's for number 13. Okay, this is number 13's work here. So that distance is 6 units. 6 units. And then number 14 says what is the value of n. That's if we know t to w, sorry, v to w is the same as v to u. So if that's 6 units, and they're saying this is also 6 units here, if that distance is also 6. One thing more we could do here if you want would be to actually label the coordinates of point U. They didn't do that. U is obviously at 0, -5 by how we've got this marked. So if we go from 0, -5 to n, -5, and we went over 6 units, then n must be equal to 6. Okay, so that's kind of just an observation by kind of thinking through some things there. So n is equal to 6. Okay, and then it says what are the coordinates of point U, point V, and point W? Well, we actually did that kind of as we went along a little bit. Point U, we just said, would be 0, -5. Point V, if n is 6, would be 6, -5. And point W would be 6, 1. Just substituting 6 in place of the n in those coordinates. So this gives you an idea of how to find distances on the coordinate plane if they are directly horizontal or vertical from each other. And just to get more practice on this, there is a lesson with Khan Academy that you could look at is distance between points, vertical or horizontal.